Hey guys, it's Vince. Today in this video we're going to be taking another unfortunate look at someone assembling a spindle cable incorrectly to support their Onefinity CNC robot. Now many of you already know I've worked on many spindle cable assemblies. I've had numerous videos on it done properly and covering best practice. This video was actually sent to me by a past client in the Onefinity community because, again, I've dealt with so many cable assemblies for that community. He just wanted me to point out some best practices and to cover some things, and I didn't realize what I was looking at until I watched the video, and it is quite long. I'm going to try to shorten it up. But first and foremost, I want to let you guys know this person did include a disclosure in his video prior to beginning. It was in reference to using an electrician prior to doing this cable assembly, and I want to clarify some things really quick because there is some misinformation online and in terms of careers being used. Electricians, guys, typically do not do soldering in terms of cable assembly work. Okay, electricians deal with usually installing cable and dealing with codes in residential and commercial real estate. Okay, there's different types of electricians. There's journeymen. I mean, it goes on and on. Electrical engineers, electronic engineers, and electronic techs deal with usually cable assembly, deal with PC board soldering, PC board assembly, and these are vastly different careers. They are reflected in salaries, they are reflected in know-how, they are reflected in so many different ways. I cannot emphasize that enough. You typically will not be contacting an electrician except for maybe how to wire the VFD properly in terms of how to connect the leads. When you start getting into an electrician programming your VFD, he most likely is not going to know how to do that. Okay, and I just want to clarify that because we need to start using terminology that's correct in the genre we're in so that we don't convolute the waters any more than we have to for other individuals getting involved. That being said, the disclosure that he used was inappropriate in terms of what career would be used to assemble the spindle cable, but he meant well in doing so. I realize that. What I see here, though, in a video, even with the disclosure, there's one thing that bothers me, and I see a lot of videos like this, and that is that he was kind enough to do the video, and I'm keeping it ambiguous, I'm not releasing any information on him. He was kind enough to do the video and release what products he was using to complete the assembly, and you guys can see right here, this is an IGUS cable that he's using for his spindle cable. But he didn't have to go through to show the actual cable assembly to still make the point in referencing what components he used to finish his own assembly, therefore not highlighting the assembly that many will follow thinking that he did the right thing. In case in point, if you read the comments, and I'm not going to go over them, many of the comments deal with a lot of different thank yous and this and that, but what's scary is they're not discussing that he assembled the cable incorrectly. And that scares me. And it should scare many of you. And again, even if we mean to do something right, it could be treacherous in the sense of safety and, of course, really, mitigating the whole purpose of using a double shielded cable, which is actually being done here. And that's why I'm saying this is so important to see. I'm going to do an excerpt of me cutting into this video showing you best practice and why we do what we do. And I'm also going to refer back to the internet to make sure what I'm telling you is not just me telling you, but is also the major source of data in this country and the world is Google. So you can see that yourself. I think right here you guys will get the gist of what we're looking at. So I'm going to start the video.
So I was getting ready to solder everything together, and I just didn't give myself enough room to play with. So if you look closely, that's the braid.
Pay attention to the leads, guys, because first and foremost, you should notice there was no flux used on these leads. As a matter of fact, as he begins the soldering assembly, there is no flux being used. This is a definitive no-no. I've covered it many times, and I'm going to define it in this video. So just let's bear with me.
Metal shielding that goes around everything. So as you start to cut this, it starts to fray everywhere. So I would say it's good to have some sort of like masking tape to kind of tape around there to collect all the little metal shavings that come up.
Now, he's absolutely right. The tin braid shield will fray. And what you're about to see is probably one of the worst demonstrations of how to remove tin braided copper shield I've ever seen. And you guys will be your own judge. but this is not best practice. It's definitely not safe, and please proceed with caution. We'll cover that in a minute.
Off when you do that. So yeah, I'm going to shave that off to give myself more breathing room with these cables. That way it's easier to get inside of these aviation connections, and then we'll go through the rest.
Okay guys, pay attention. He's using a box cutter, virtually hacksawing through all of the tin braided copper shield. And I'm assuming he thinks he's not making any damage on the actual conductors. I don't know how he would think that, because it takes a pretty decent amount of tension to go through that tin copper, and it would definitely permeate through the mylar foil underneath. And again, we're dealing with IGUS cable, so this is very, very high quality, expensive cable. I can't believe what I'm seeing. Then he's flexing the cable. And again, I'm going to highlight this. This is extremely dangerous. If he's cutting through the casing to the conductors, as this cable flexes, you will have potential issues over time.
Now I want to demonstrate what we saw. We saw the individual going through. He cut the casing. Okay, once the casing is cut, we're going to make an incision across. Once that's done, you can then come in with a probe and carefully, I'm going to make sure we find that incision line. See if I can find it. Once I fracture that, you see I didn't go all the way through. Then I'm going to come back and peel it like a banana. Boom. We got everything off. If you get any that sticks, just go over it with your razor real easy and just touch it, and it'll come right off. Now this is for any cable, okay? You got your tin braid, you got your shield drain, you got your mylar foil. What we saw him doing was hacksawing like this. If you do this around the entire cable's perimeter, odds are you're going to go right into your lead's casing. Okay, and I don't think the individual knew that was doing the video, but that's exactly what he's doing. There's no way the pressure that he's cutting tin braid is not exceeding that of the casing to incise it. So you have to be very cautious. What you should be using is a set of flush cutters. And you'll come in here, and what I prefer to do is actually lift it away, and then I come in and I cut. And in this way, when you cut, as you cut vertically down, you're never incising anything. So everything comes this way, and then once we fold out our tin, we can then trim. And you trim right up to the casing, and that's why it's called a flush cutter. You'll come up and trim this right off. And you'll see you'll just go around. And what do you got to do? You got to keep flaring them out so you can get a clean effect. And that's where the probes come in. So again, this is a tedious process, and it needs to be respected. When I see somebody actually doing what he did, unknowingly, of course, he's, you know, trying to show you the right thing in terms of what he's done. But unfortunately, the odds of you going through any of this casing and making a slice where, once again, it's like this, you're essentially asking for trouble. Now, I get guys that say, well, even if he did slice through it, the casing is still present, and technically you're not going to have any shorts because the casing is there. Well, let me explain something to you guys, okay? And this is where things get kind of convoluted. You are building an active cable. When I say an active cable, these cables move. They're not cables like you'd see in a computer or, you know, what you'd see in typical electrical outlets and stuff where they're stationary. Active cabling will always be moving to some degree. When you cut anything like this, especially a lead, this PVC over time will separate from movement. And we don't know how much movement, but we know it's possible. And therefore, it needs to be taken into account, especially when you're dealing with a three-phase cable. Just so everybody knows, three-phase means 3 of these leads are hot. That means each lead is providing over 100 volts and in order to power your spindle. That's why there is so much attention to detail with these cables.
Needless to say, this is not best practice and should be avoided at all costs.
Okay, so now that I've stripped back the cables a little bit, gave myself more wiggle room there.
You can see, guys, you can see the leads. You can see how there is no smoothness to how the solder is applied to the conductors. And that tells you that no flux was used. That's why it's blobby.
The little sleeve back on from there. One thing I noticed is that they're all black, but you can faintly make out they're numbered. So that.
Case in point, I'm just going to make everybody aware you're all black because typically it's a 3-phase power cable. So all leads are the same, guys. Whether they number the cable or not, this is hot, hot, and hot, and of course green would be your ground.
The 3 on that one. The green, this is the green, but there's a 1 on this one. So when I have to cut the other end,
we can see we still have, it looks like a yarn slice coming through. This is definitely not a clean cable, and you guys will definitely want to pay attention to that.
Okay guys, I'm on the bench here and I've got one of my pieces for demonstration purposes of my 16-4 double shielded spindle cable. This is not my UltraFlex DS Flexion, this is my standard spindle cable, but for demonstration purposes we've got an HY large connector, no tinning been done, and we have exposed leads. Now what you'll first notice is that on the casing, and this happens in a lot of videos, you'll see that the end user leaves strands of tin braided copper, if it's double shielded, along with mylar foil sticking out of the casing. This is not best practice. The reason it's not is, God forbid, one of these 3 power leads actually fractures and makes a connection to any of that ground, you're going to have a dead short, and that can instantly start a fire. So again, everything should be actually pushed back into the casing, and you can see how clean this is. You can see everything is nice and clean. There's nothing protruding out of that. You will require probes to do that, with like I'm holding right here. I also have nylon ones, depending upon what I'm working with. Okay?
Shrink wrap tubing on here. When I cut the other end, I should be able to see the 1, 2, and 3, or at least the 1 and 3, I don't know which one's 2, to connect to the VFD motor. So
once again, guys, it's irrelevant, and this also defines his competence in this. And again, I'm not making fun of him. I'm stating if all 3 leads are hot, it's irrelevant in which way you connect it to the motor in UV and W, because they're all hot. The only one that matters is the ground. So again, you don't have to be that technical on a 3-phase, because again, each lead, once again identified by the black casing, identifies it as a hot lead, and green being ground.
Yeah, that was the 3 and the 1. So now I'm gonna put on.
Here's where I cringe the most, because this is what we typically see when somebody did not either do the research. In his case, he claims he researched, or he didn't spend the money on the proper tooling, meaning solder and flux. I would also use a jig of some sort. What he's using on the angle he is, very hard to solder with. You'd want to use something like a mini vise, pan vise, something of that nature.
On some shrink wrap tubing on each one of these, just as a little extra protection once I start to solder. Once again, I'm not a professional at this, but you know, I've watched enough safety tips.
Okay, I'm not going to go into what he just said there. What we know about safety is here nor there. When we see that flux is not being used, I'm going to break over real quick, and I want to just show you something. I'm right in Google search, and I'm going to just type in, do I need flux? And you can see as soon as I wrote that, it says, do I need flux to solder? And what does it say? Doesn't matter how much you clean your metal surface, you'll need flux to make the solder stick. Without this, a solder joint simply will not be strong enough or conductive enough, which is why soldering with flux is recommended. It's not that it's recommended, it's mandatory, guys. It's mandatory for this application. I cannot emphasize this enough. You are dealing with a three-phase cable, and the voltage involved with three-phase is terminal. Please take that into consideration.
Try to do it right. So green is my number 4. Everything I've looked at says that is correct. So I'm going to get a little clamp here. Use my Bessie clamp here to hold this steady for me. Have another set of hands. And so that's 4. That's where I want to solder into.
Once again, we see no flux being used. He's got the actual connector on an articulated angle with like some type of bar clamp or just a shop clamp. Guys, please be careful. This is very, very dangerous what we're dealing with here. And you'll see as he goes through and he speeds up the process, I want to show you the connections when he's done. And I really wanted you to pay attention to these. It's very brief. It's not pretty. Okay. I'm not sure if everyone can see this. You can see how blobby we are, and then we have these gaps. You see that big gap right there in that conductor? Guys, this is not properly soldered. And he's going to fast forward through this using his individual lead heat shrink. I don't use individual lead heat shrink. I get that question a lot. I just go over the entire connector. Main reason I do is, first of all, I use double wall heat shrink with adhesive. This is just standard heat shrink. And the reason I don't is because with a solder flux connection, and when it's bonded with the actual adhesive backed on the double adhesive, or excuse me, double walled heat shrink, you're not going to have movement once that dries. This will work either way. It's what you prefer. And the other factor is, the only reason he was able to use individual lead heat shrink is because he cut back his lead so far as the casing to give him more room to work, because he's not used to, once again, working on cable assemblies. So let's see exactly where this goes. Once again, you can see the gap there, gap there. These are completely unfilled with solder. I'm hoping he filled them up to some degree. Again, it's nowhere near the safety you're going to have or optimal best practice using flux.
The other thing I want to show, and this is real quick because I've discussed this many times before, and that is understanding the importance of flux. And why, if you're going to solder, you require flux, especially for safety and especially for a three-phase power cable, okay? With this, you can have what's known as a contact point soldered, and yet you may find that what appears to hold up can snap off. and that's because you don't have maximum strength because you're not using flux properly. I got the iron already heat up here. Okay. Now what I'm going to do, and I'm just going to show you this, with no flux, I'm going to do exactly what you typically see done in most of these videos. They think that by using a high quality solder, and I'm using Kester number 44 right here, that you're okay soldering these without flux. And I'm going to show you what happens, even if I go to tin this without flux. Here's what you're going to get. And the guy sits there usually for like 30 minutes, and he's over here wondering, why isn't it spreading? Why isn't it spreading? It's something wrong. I can't get this to spread. I hear it all the time. You can see it did absolutely nothing. Here, I'll take some more. And what they keep doing is keep adding it and adding it and adding it because they're not looking at what's actually occurring. You don't have a clean conductor. If I go now to solder this lead, mind you, these leads are tinned. If I go to solder this lead, and I'm doing this once again, let me just bend that. Let me just bend that out of the way. The shield drain. Here's our ground. If I go to solder this, look at what happens. Nothing. Nothing is occurring. You have no transfer of anything. And there you go. You're just heating and heating and heating. And then they get this. They get a blob like that. And they go, oh, that's soldered. That's when they stop. And this is what I typically see in all these videos, and it's terrifying. When you have gaps like this in the conductor going to the actual, the other conductor on the opposite connector, when you have the connector's terminal, and you have an air gap like that, I can actually fit the probe in there. This is not a properly soldered connection. If you do not use flux, and these are not cleaned, and you don't have a proper tin on these, and you don't have penetration all the way back to the conductor that the connector is attached to, you do not have a solid connection. It may appear solid, but this is not right, guys. And I say this because it's terrifying to me. Now watch what happens when you use flux. This is Kester 186. It's all I use. It's what I sell. You can see I just touched it with some flux. Now watch what happens. Same amount of solder. I'm just going to touch it. You'll see a sizzle. Now I touch, and and you see how it's spread totally evenly. Okay? Totally evenly. It's not even the same. If you do it again, and you were to conduct, and I'm just doing this, I'm just messing around here. I'm going to just put the shield drain on top to give you a visual. And I want to just show you how quick flux works. And the shield drain is a good example of this. I'm going to apply flux to it, and I'm going to show you how you do this. You're going to apply it to where it's wet. And you can see the flux is actually flowing. Now watch what happens when I touch this conductor. And I just follow it down, and you can see, look at the color, look at the penetration. It's totally different. I usually do this twice, and I'll do it from the bottom, so we know that the leads are totally penetrated. You can see a totally different color, and you can see how this looks right. When I say that, I get a lot of guys that go back and forth with me on it, and it's not even the same. Now I'll fill the cup up. I'm just showing you for demonstration. I would normally do a full tin where this cup is fully filled, but watch what happens. I'm going to come in, and I'm just going to hold. Watch the transfer. There you go. Transfer is occurring. There it goes, and you'll see it level. Now it's bubbling. Amazing. Amazing. So when you see this, and again, this is not a fully tinned cup in the sense I didn't even fully tin that. Imagine had I fully tinned it, what you would see. But I wanted to do this so you could see the difference, and you can totally see the difference in the connection as far as how this is done. And if you're reworking it, it's the same principle. You would normally come in, touch. This is why flux is so important, and quality flux for the right application. I've seen guys using plumbing solder. We're going to touch, and you can lift this right out. Boom. If you see a blob like that, watch how flux works. Gone. See, you're not going to get that any other way. Is flux expensive? Yes, it is. For good reason. First of all, is it expensive compared to your life, potentially? I don't think so. Or your loved one's life? I don't think so. So, again, we're trying to do things correct. when trying to do things correct and we're trying to illustrate the purpose. Now, let me state once again, I'm just doing this for illustration purposes. That's why the leads are so far back. You've seen my videos before of how I assemble these. But again, this must be done with precision. And when I see guys doing that kind of work, and then they say, oh, my work is ugly, it's way more than just saying your work is ugly. This is a 3-phase power cable. Take it serious, guys. Take it serious. It will start a fire. Even if you're not going to get electrocuted, God forbid, it will start a fire. And once again, you can see the difference. Look at the chrome finish there, and you have a very, very dark finish here. That's why using flux is so important. You can see that chrome finish on the braid. It penetrated perfectly. This is now one solid lead. Okay? So again, it's all about doing it in that same fashion. If you're reworking, it's the same thing. Make sure I put enough there. I don't think I put any there. Come in, a little solder. Now I always use a little contact solder. It's up to you. I don't like to overheat the conductors. If I don't have to, I'm just going to remove this. And you see, it's all about jigging your hand and touching, and it'll come right off. And again, it's amazing to me, even if flux has not been used on the first round, if you use flux again, and you touch, you'll see that whole lead. And I'm just showing you. Now, typically, when you tin this, you would want this connector vertical. Why? Because gravity is going to pull your flux down. So, again, this gives you a better view. I'm just holding it. And you can see how that cup is now starting to get full. So, again, everything here must be done correctly. But you can see the difference on the finish of the actual solder.
And he said, but it will hold. I find that questionable.
So now I'm going to drop all the shrink wrap down and cover all of those up. And should be good. Alright, so here's where I am. So I have my shrink wrap on my tube. Everything is double protected, so it's tinned and soldered in there, and then it's all shrunk wrapped, so just in case any mistakes I may have made, they're all nice and covered up.
Guys, I'm not here to poke fun. I'm just stating a fact. Just because it looks neat with heat shrink over it doesn't mean the problems go away. Okay? I'm just letting you know, we don't know how this cable is going to hold up over duration. Okay? One thing I want to point out once again, and he did this right. He did terminate it in the proper location. He used the green ground lead to the ground conductor. He did not attach the shield drain on this end, which is correct. He is to attach it on the other end with the VFD. We're about to go over to that assembly side. Something else I want to point out, you can see he's using the silicone boot. I don't use silicone boots when I assemble spindle cables, and the main reason I don't is it's way too flexible over time. I use double wall heat shrink creating the boot. And therefore, when you use double wall heat shrink, and I use another internal piece of heat shrink underneath the first layer of double wall, and it makes it very rigid, more like a molded on connection. I find over time it lasts basically the life of the cable. And again, safety is everything. At 600 volt rating, when we're using actually two pieces, one to over laminate the first insertion, it definitely makes the cable, number one, it makes it presentable in a fashion that most people have never seen, in the fact that it looks molded, and of course it will last the life of the cable. Maximum safety. Once again, doing the same thing he did wrong the first go around.
Alright, so as you can see there, you have the metal braid, and then another thin protective shell, and then bare wire. So, like I said, be very careful as you just kind of score across the metal shielding. You really just want to kind of break the tension in the wires. If you go too deep, you're going to go through that plastic coating.
And that's exactly what I'm discussing. And if you want to believe that he didn't do that, God bless him. Because I'll tell you what, I've never seen anyone cut any shielding like that in a way that wouldn't actually permeate that cable. So I hope he did not score any of those conductors. Now we'll go through, watch him do some tinning. This is very interesting. He's tinning the conductors. And when I first seen this, I thought, oh, okay, he's tinning them. He's just following the same thing he did on the other end. Of course, he's not using flux, not best practice. I wanted just to see how he actually connects the ring connectors. And this is interesting, so please watch this.
So as I mentioned earlier, part of the reason for tinning the wire is that when I slide this on, I see that a lot of it sticks out. So what I'm able to do is cut about half, and I have no frayed wires. No little pieces of copper or anything. It just snips down, and then all I have to do from there is twist this back on, and I can see a little bit right at the top where I need it for connection purposes, and just crimp it down.
Okay, so we already know, anybody who's dealt with any type of crimp connector, you do not solder first and then apply a crimp connector. That's the first no-no. The major no-no is the fact that he's using crimp connectors at all on a cable that's under tension. And what I mean by tension, guys, is these ring connectors will be inserted onto his VFD's terminal block, and there is some slight tension on these leads on the cable when they are applied. So when you think of it over time, you do not know if these crimp connectors are going to be bonded like a solder connection. Now, I still have guys, and there's still a lot of people that have this debate, it's kind of like a Ford and Chevy debate, where they say crimp connectors are just as reliable as solder connectors. Really? Okay. And my argument's always been the same. First and foremost, in my genre of work with CNC, 98% of our connectors are aviation connectors. And all of the aviation connectors are solder type. It's interesting, if that was the case, why aren't we using more crimp connectors? We're not. And again, when soldering is done properly, you will always find, when it's precision electronics, it will be soldered. Under all preferences, with all things being considered and proper best practice being followed with solder, flux, cleaning, and appropriate measures, they're always going to solder. The tensile strength on solder, when it's actually applied correctly with flux, is amazing. And when I say amazing, like I've said in many previous videos, you would actually have to destroy the connection as far as the lead itself to break that bond. Okay, and we're talking tensile strength. When we see something like this, he's hoping he crimped this with enough power that everything is bonded. I cannot tell you how many times in my shop I have seen crimp connectors fail. And I mean openly. I've had clients send me their motors back, they used crimp connectors or did some type of assembly, and they couldn't figure out what the problem was. And then we looked, and when they crimped, they either fractured some conductors internally. There was all kinds of other issues done. When you look at high-end electronics, when you look at aviation connectors, soldering is always done. Your iPhone, if you look inside of it, all of it's solder connections. They're not using crimp connections. And believe me, with assembly purposes, it's always the cheapest way to go because it's much faster. That's why we see it done in this industry so much, because when we're doing mass production, it's much cheaper to do a crimp connection than a solder connection. Anyone will tell you that when flux typically goes for $80 to $100 a gallon. And I could tell you because I buy many of it, okay? So please keep that in mind. Tensile strength, again, on these connectors should be maximum, and that's why solder should be used. And I say that openly, and I say that in all my videos, but I still get a lot of pushback, and you guys are going to do what you want to do anyways. We see it being done here, but please be safe. And this is, again, he's using crimp connectors that are soldered first as far as tinning the leads, which I don't know what the logic was behind that, because I mean, again, if you do Google research at all on that, on any type of crimp connection, you do not tin the leads first. Now, I'm a big believer in tinning them after. He could have crimped first and then went over it with solder. That works fine. You can definitely do that, get a mechanical and the metallurgy bond. That's fine. But you do not do it in this fashion. This is not going to give you the longevity and the safety that this type of work deserves.
Nice snug connection.
Okay, and now I'm going to wrap this up right about here because I think now we can see where we're going. You can see right here there is no shield drain. Okay, and just to clarify what I'm saying, if there's no shield drain coming up to this ground where he's going to terminate it on the VFD, this cable is ineffective, guys. He didn't follow process enough to understand that without shield drain present and grounded, his cable is not doing anything more than transferring power like a standard cable. So he's defeated the purpose of using a double shielded cable.
That's why there is so much attention to detail with these cables. Okay? The other thing is, the individual in the video did not use the shield drain. And you'll see that in the video as we go through. The shield drain must be attached to the ground on the VFD. If you do not use this shield drain and you cut it off and just use the cable as a standard cable, that's exactly what you have, eliminating the actual whole purpose of using double shielded cable. The idea is that this shield drain catches and mitigates EMI and dissipates it to ground. And that's why it's so important to have that.
You'll mount everything, and there you go. There is no shield drain. You can see nothing here being grounded. He then goes in and uses a standard power cable to power the VFD. Now, I'm going to ask you guys a logical question, and this is something that I've discussed many times on my channel. If you're using a double shielded cable for your spindle's power cable, why would you use a standard cable to power the VFD? Because it's just running power to the VFD, but it does the same transmission from the VFD as far as EMI as it would on the opposite end powering the spindle. So we should, in best practice, use a double shielded cable powering the VFD and a double shielded power cable running our spindle. I'm just clarifying that.
I hope that this portion of the video has been helpful.